Hi everyone, welcome to my channel STB Student the Brand, that is Units and Measurements. Today topic is Units and Measurements, Chapter 1, CBSE Physics, Class 11. Algebraic operations with significant figures. Those are, you can take here, addition and subtraction, multiplication or division, error analysis, classification of errors. Here, algebraic operations with the significant figures. So what exactly the algebraic operations with significant figures? Normally, when you are doing algebraic operations, those are addition, subtraction, multiplication, division, like that, whatever the digits are involved, so based on that how the result will come, so we'll discuss in this. So the final result shall have significant figures corresponding to a number in the least accurate variable involved. Means while you're doing these operations, when it is involved the least operations, then you will get the corresponding values. Suppose you can take addition and subtraction, both you are considering. Suppose in the measured values to be added or subtracted, so here you can understand clearly the measured values to be added or subtracted, the least number of digits after decimal. So you can take 23.4, 23.67, 23.876. So here you can understand the least number of digit after the decimal, okay, is n. Suppose you can consider that number is n, then the sum or difference also, the number or digits after the decimal should be 1. Okay, suppose we can take addition we are considering. So here we can take 1.2 plus 3.45 plus 6.789. So this value if you add, you will get 11.439. 11.439 you'll get. So then that will become almost equal to 11.4. So here you can understand by this example. So here the least number after decimal, what is the least number? 2. So that is 1 number n, right? So after the final result, we got the final result. So here after the decimal, how much we got? 1 only, that is n. So that is the meaning of the statement. And one more you can consider, this is addition we consider. Next one you can go for subtraction. So subtraction, if you take subtraction, now here I'm considering 12.63 minus 10.2. So here what is 12.63 minus 10.2? You will get 2.43, that is approximately equal to 2.4. So that is equal to 2.4. Yes, then we can consider. So here you can understand the least digit in this subtraction is, that is 2. So that is n. Here also after result, after getting result, after decimal you got n is single number, that is 1. So I hope you got to know. Then multiplication or division. Here you need to understand, suppose in the measured values to be multiplied or divided, the least number of significant digits be n. the least number of significant digits. Then the product or coefficient, the number of significant digits should be also n only. So suppose I am taking example 2.12 into 36.72. Here if you multiply, you will get 44.063, 44.0 sorry 064 you will get. So that is almost equal to 44. So here you need to understand what we said when suppose in measured values. So here you need to understand measured values to be multiplied or divided the least number of significant digits. Least number of significant digits means 1.2. Here it is 1.2, right? 1.2. So after multiply or divided, so you'll get the value is 44. Those are the two significant figures, right? So I hope you got to know. Then so we can go for one more. Next topic is, that is error analysis. That is error analysis. So we know that no measurement is perfect. You measure with the scale, you measure with the screw gauge, you measure with the vernier calipers, you measure with any instrument. No measurement is perfect. Every instrument can measure up to a certain accuracy. Certain accuracy. So any instrument you take, any instrument, the measured value will be a certain accuracy. That is called least count. Okay, every instrument can measure up to a certain accuracy is called accuracy called least count. So least count. So what is the least count? So what exactly it is? So here see, the smallest measurement that can be measured, the smallest measurement that can be measured accurately by an instrument is called its least count. So by scale you take, so we can measure, like, so certain measurement will be done by an instrument accurately, certain limit only, certain value only, right? The smallest measurement that can be measured accurately by an instrument is called least count. Clear? Yes. So here you can observe carefully. So here they given so you get scale, that is how much? So 1 right? And one more thing you can consider, vernier calipers also you can observe. Vernier calipers, that is 0.1 Next, screw gauge also 0.01 Next, stopwatch also 0.1 second. Next, temperature thermometer. By using temperature thermometer, so the smallest measurement is 1 degree centigrade. So by this we can understand that is least count is nothing but the smallest measurement that can be measured accurately by an instrument is called its least count. So I hope you got to know. Next, permissible error due to least count. What exactly the permissible error? Yeah, permissible error due to least count. Error in a measurement. So what exactly here it is? Error in measurement due to limitation or least count. So here in the previous year you see until 1 can be measured, until 0.1 only can be measured, until 0.01 only can be measured. By scale we can't measure this value. By vernier calipers we can't measure this 0.01 value, right? So certain limitations are there. Right? That is the reason here you can understand error in measurement due to the limitation or least count of the instrument is called permissible error. What is that permissible error? Error in measurement due to the limitation. Due to the limitation. Very good. Least count of millimeter scale is 1 mm. Therefore, maximum permissible error in the measurement of the length by a millimeter scale is 1 mm. By millimeter scale, how much we can able to measure? 1 mm. By centimeter scale, 1 centimeter. So by you can take by screw gauge how much 0.01 mm, by vernier caliper 0.1 m. So by this we can able to understand. Next one, so very important, very one example we can able to consider. So here I will take 1 mm by say. So length you can take 26 mm suppose. So one example we'll see, then we will go for classification errors. L equal to 26 mm, right? So what I said, the maximum error can be 1 mm, right? So we can take L equal to 26 plus 1, that is we can add, so 27 mm you will get. So we can also take L equal to the minimum value. This is the maximum value, right? Maximum error, this is the minimum, right? So minimum value is only 1 mm, right? So 26 minus 1 you can take, that is 25 mm. So the measured value can be written L equal to 26 plus or minus 1 mm can be taken. The minimum and maximum value will be written like this. Clear? Okay, done. Good, great. Now we will go to the classification of errors. So based on what the errors can be classified? Errors can be classified based on errors can be classified in two ways. So how many ways? Two ways. Very good. So what is the first classification? First classification is based on cause of error. First classification is based on what? Classification of error. How many errors are there? Two ways. How many errors? Classified two ways. Based on cause of error, that is the first one. What are the example? Systematic error and random error. One is systematic error, another one is random error. Second classification is based on magnitude of the error. Second classification is based on what? Magnitude of error. Very good. So example, absolute error, mean absolute error, and relative or fractional error. Relative or fractional error. Very good. So how many ways these errors are classified? Two ways. What are based on what? Based on cause of error, example, systematic and random. Second classification is based on magnitude of error, absolute error, mean absolute error, relative or fractional error. Very good. Nice. Next one. So the first one you said, that is cause of error. First one is systematic error. How this systematic error occurs, how to rectify this systematic error, we will see here. Systematic errors are errors whose causes are known to us. Wow, very nice, great. So systematic errors whose causes we know already, how it will happens. So what is the cause? What is the reason behind of that error? We already knows. Then automatically we can rectify, right? Yes, how to rectify? So such errors can be minimized. Yes, if you know cause, if you know your pain, so how you got that pain, then automatically you can reduce that pain. Yes, I know you got less marks in exam, you got less marks in exam, right? So you know where you lost the marks, where in which concept you lost the marks, how to rectify that mistake, you know that, then automatically you can rectify it, right? You can able to rectify, right? Yes. So that is the systematic error we can take. Following are the few causes of these errors. So we will see the causes. What are the causes first, then we'll go for the next one. Instrumental error may be due to erroneous instrument, means default instrument or mistakes in instrument are not designed properly. Like these are the example, erroneous instruments. These errors can be reduced by using more accurate instruments. So instead of using this one, we can replace with the correct designed correct values no mention in the instrument, that correct accurate instruments if you take, then we can able to reduce or minimize these errors. Or so making that error, so without error, so we can make it as a zero, like that we can able to reduce it. Sometimes errors arise on account of ignoring certain facts, like when you are mentioning when you're finding the time period of pendulum, so some air friction also will be there, right? So friction of the air, so if you're not considering that one, so again it's a problem, certain mistakes will be there. So by using suitable formula we can able to rectify those mistakes. Then change in temperature, pressure, humidity may also sometimes causes errors in the result. Relevant corrections can be made to minimize this effects. Wow, so till now we saw that systematic errors, how it will occur. So what are the things we need to do to rectify these error, right? Next, random error. What is random error? Random error is nothing but, so the cause of random errors are not known, so we don't know exactly how this error is occurring, how it is happening, we don't know, right? That is called random error. Randomly it happens. Sometimes you want to go to school, suddenly what happens, if rain comes, then there is a random error, so we don't know that error, suddenly rain will come, then so we can't go to school, so we can't go to college, we can't go to office, so we'll stay in home only. That is random error. Sometimes means suddenly it happens, so we don't know even that cause, so suddenly it will happens, like that example I took. Okay, hence it is not possible to remove them completely. So suddenly rain comes, we can't do anything, right? So we have to minimize, how, by wearing a raincoat, by taking the umbrella, then we can do our work, right? Here the random errors can be minimized by repeating the observation a large number of times. Okay, so normally what happens, so if you want to measure the length of the table, you use scale. Initially you'll measure one value will come, one result will come, again you'll measure, one more value will come, again you'll measure, one more value will come. Okay, there won't be any matching, then how to rectify this? So you have to measure number of times, so 3 5, so you can take, so by seeing that one you can take the mean value, average value, then you will get that accurate value. So that only they given, the mean value would be very close to the most accurate reading. So then we can take, so a mean equal to, so this is the first observation, then second observation, and so on, n observation, so how many times we observe, that we can take. So that is random error. Next one is absolute error. What is absolute error? The difference between true value, so what exactly the value of the measurement, the value of the measurement. So I'm taking this table measurement, so exactly what the value, length of the table, right? So 200 meters you can 200 centimeters you can take, 200 centimeters, like that. So the measured value of quantity is called an absolute error, and The true value, the difference here you need to understand very carefully. The difference between true value and measured value of a quantity is called an absolute error. Usually the mean value is taken as the true value. Mean value is taken as a, that is true value. Okay, mean value. So you can take am also, you can consider this am the mean value. So am only, right? In mean value you are taking this here only, right? So here only we are considering, so we can take am. Okay, done. Great. So am equal to, what is that? A plus 1 plus a2 plus and so on, an by n. Good. Now m is with the measured values. Now find the difference. So we will find the difference between am with the measured values. Measured values is this only, right? A1, A2, A3 like that. So delta A1 equal to am minus A1. Delta A equal to either positive or negative, we can consider. So here delta A2 equal to am minus A2, delta A3 equal to am minus A3, and delta A4 equal to delta am mean value minus fourth value. Okay, so by this, and delta an also we can consider equal to am minus an, right? So we can take like this. Here delta a1 comma delta a2 and so on, delta an be positive or negative, but their magnitude absolutely positive. Their magnitude will be always positive, always positive, is called absolute error, is known as absolute error. Understood? Clear? Yes. Okay, done. So we got it. Next one, mean absolute error. What is the mean absolute error? Arithmetic mean of magnitude of absolute errors. So what are the magnitude of absolute errors? Here I also know delta A, delta A1, delta A2, and delta A3. Okay, so delta is always, it's a positive. So these are absolute errors. So the mean value of, here you can take arithmetic mean, sorry, arithmetic mean of the magnitudes of absolute errors. Absolute errors means delta a1, delta a2 in all the measurements is called mean absolute error. So we can take delta a mean, delta a mean you can consider that a mean means, previously a mean means a1 plus a2 plus and so on by n. So delta mean means, delta a mean means delta a1, so absolute error means not always positive, delta a2, then so on, delta an by, we can consider en. Okay, so the final resultant can be written. So what are the final resultant? That how we will write a equal to am plus plus or minus, also you can take delta a mean. So what is that? A equal to a mean plus or minus delta a mean. Okay, so here a lies between. So a lies, where it will lies? A lies between am plus delta a mean, and so am minus delta a mean. So a lies between these two values, plus and minus, maximum minimum we can take. Next one, next error is relative or fractional error. The ratio of mean absolute error. What is the mean absolute error? Delta a mean to mean value a mean. So of the quantity measured is called relative or fractional error. Relative or fractional error equal to relative error or fractional error equal to delta mean. Okay, absolute error. So the mean of absolute error by mean value, mean value. Okay, so relative error expressed in percentage is called percentage error. If the error is uh, expressed in percentage, so into 100, then it is called percentage error. Percentage error also. Percentage error we can take. So same we will write. So if you're taking percentage error, this 100, we will write separately. That's fine. Delta A mean by AM equal into 100. Then we will get relative or fractional error. So here onwards, it's very important. Listen carefully. Combination of errors. Errors in sum or difference. Let x equal to a plus or minus b. Let x equal to a plus or minus b. Further, delta a, if you take absolute error in measurement of a, delta a is absolute error in measurement of e, delta b is absolute error in measurement of b. So here a and b are there, no? So these are absolute errors, and delta x is absolute error in the measurement of x. So now we can write this one, x plus delta x equal to a plus or minus delta a plus or minus, you can also take this one. Then we can consider here b plus or minus delta b. So here what we can take common, here we can take common a plus b, we can take common from this. So how you will get a plus or minus b, if you take common, then you will get, so actually plus or minus also there in the middle, so that we will write. Okay, so here you will get plus or minus delta a and plus or minus delta b. Okay, so here you can take a plus or minus b plus or minus, here it is there, plus or minus delta a plus or minus delta b. Then we can take, so you know here what is plus or minus delta a, that is x value only, right? That is x value. So x plus or minus delta a plus or minus delta b, plus or minus delta b. So here you need to understand, here also it is there delta x. Okay, so here x has get cancelled, here this x and this x will get cancelled. What will be the remaining? So remaining is delta x equal to, you can, sorry, here you can take the delta x equal to plus or minus delta a plus or minus delta b. Okay, now the four values of delta x. So what are the four values of delta x? So we can see these four values of delta x. What are the values? First, delta a minus delta b, one value, and delta a plus delta b, very good. Then minus delta a minus delta b, very nice. Then minus a plus, we can take like this. These are all the values of combination of errors. The maximum absolute error in x equal to, what's the maximum absolute error in x? Delta x equal to, so what is that? Plus or minus delta a plus or minus, oh maximum you said, no, that is maximum if you are taking, so plus only we can consider. Then we can take delta b, right? Yes, so this is a maximum absolute error in x. Maximum absolute error in sum or difference of two quantities is equal to the, so maximum absolute error is equal to the sum and difference of two quantities is equal to sum of the absolute errors in individual quantities. Sum of the absolute errors in individual quantities. So by that we can understand. Okay, so next one, errors in product. Next one is errors in product, we will see. So let's consider here. Very good. So be patient, but it's very important concept. So let x equal to AB. Let x equal to AB we can consider. And now previous, so how we did same thing, this also we can be taken. So how it is, x plus or minus delta x equal to, so a plus delta a plus or minus, already said, plus or minus into, so here product we are considering, so that's why we are considering product only. Here we can take x common here. If you take x common, what you will get? 1 plus delta, 1 plus or minus delta x by x, carefully you can see. And here ab we can take common. AB if you consider 1 plus or minus delta a by a, and here 1 plus or minus delta b by b, means in this part we can take, in this part we can take a common, and in this part we can take b common. So we separated it. We know, so what is ab? That is equal to x. So substitute ab value in this equation, then you will get x equal to 1 plus or minus delta x by x equal to x. Then you will get 1 plus delta a plus or minus delta a by a plus 1 plus or minus delta b by b. So here this will get cancelled, right? Both terms will get cancelled. So a get cancelled, sorry, xx get cancelled. Then what will be the remaining? That is 1 plus or minus delta x by x equal to 1 plus or minus delta a by a and 1 plus or minus delta b by b we can consider. Now here we can see, if you multiply these two, so what you will get? So 1 plus or minus delta x by x, if you multiply this one, 1 plus or minus delta b by b, delta b by b plus or minus delta a by a. So means first you have to multiply with this, okay, like this you have to multiply. So 1 plus or minus delta b by b plus or minus, so you are multiplying next like this. So delta a plus or minus delta a by a plus or minus, here if you multiply delta a by a dot delta b by b. Okay, now so here both side 1 is there, no? So 1 can be cancelled. Then we can take what is the value, remaining value, plus or minus delta x by x equal to plus or minus delta a by a. So remaining terms I am writing, so this term and this term and this term, plus or minus delta b by b plus or minus delta a by a dot delta b by b. Okay, so here if you multiply these two, you will get square. So this term is very small compared to remaining, so this can be neglected. Okay, then what you will get? So plus or minus delta x by x equal to plus or minus delta a by a plus or minus delta b by b. Okay, so now you got, sorry here. Okay, now you got the answer, this one, very nice, clear. Now the possible values of delta x by x. So what are the possible values of delta x x? So now we will see how, what are those. Delta a by a plus delta b by b, that is one positive value. First we have to take plus, then minus plus, like that. So right, delta a by a minus delta b by b, okay, minus of delta a by a plus delta b by b, and we can take minus delta a by a minus delta b by b. So these are the possible values of delta x by x. The maximum possible value of delta x by x is, so delta x by x, the maximum possible value equal to plus or minus delta a by a plus delta b by b. That is, the maximum fractional error in product of two or more quantities is equal to sum of fractional errors in individual quantities. Sum of fractional errors in individual quantities, right? So that is about error in product. Now we can see error in division. Error in division. Okay, so now we can consider carefully. Let x equal to, what is the value, a by b. A by b we can consider. Then that is x plus minus delta x equal to a plus or minus delta a by b plus or minus delta b. So we consider like that. Now we can take common here. We can take x plus or minus delta x. Sorry, here after taking x common, we will get 1, right? Yeah, 1 we will get. So then we can take, right, 1. Then x by x equal to a by b. Here we are taking a by, so individually common we will take. Instead of this one, we can consider individually. That is, a you can take, what you will get, 1 plus or minus delta a by a by b. You can take common, 1 plus or minus delta b by b you will get. Now what you will understand by this, we can see, observe, what you will observe, x equal to a by b I can observe. In the place of a by b, x I can substitute. Then you will get this get cancel. Okay, what is the remaining term? Then you will get 1 plus or minus delta x by x equal to 1 plus or minus delta a by a. Okay, very nice. Then here is the term 1 by x. How we can write? X power minus 1. 1 by x square, we can take x power minus 2. So here is our term, that is 1 plus or minus delta b by b. So how I will write? Can you suggest me? Okay, nice. That can be written 1 plus or minus delta b by b whole power minus 1. Wow, very nice. Thank you. As delta b by b very less than compared to 1. So if you're expanding binomially, binomial theorem, with the help of binomial theorem, you'll get the final value 1 plus or minus delta x by x. That is equal to 1 plus or minus delta a by a, and so on, 1 plus or minus delta b by b. Okay, then what you will get? 1 plus or minus delta x by x. So here if you multiply, I already said one method, you have to multiply first 1 with 2 terms, then delta a by a with these 2 terms. First we will see 1 plus or minus delta a by a, so 1, then this next. Okay, so even if you take delta b by b plus or minus delta a by a dot delta b by b, clear? Yes. So anyway these values are smaller quantities, so after multiplying, so you can remove that, then you will get, after removing this plus 1 get cancelled, then plus or minus delta x by x equal to, what will get, plus or minus delta a by a plus or minus delta b by b. Okay, so possible values, maximum value you already know, then you can go for it. That is delta maximum value of delta x by x equal to what, delta a by a minus delta b by b comma delta a by a plus delta b by b comma minus delta a by a minus delta b by b comma minus delta a by a plus delta b by b. Correct. Maximum possible error of x is delta x by x equal to plus or minus delta a by a plus delta b by b. Clear? Yes. So errors in division. So see carefully. So once again rewind the video, you can check. Next, the last topic is error in quantity raised to some power. How it can be? So take take x equal to a power n by b power m. Okay, then if you take log, then we can take ln x, you can consider. So here and an, so for a I am taking ln log minus m into log b, you can take. Then if you differentiate on both side, if you differentiate on both side, what will get, dx by x equal to n into dA by a minus m into dB by b. Now fractional error, if you convert this one into fractional error, then delta x by x equal to plus or minus n into delta a by a, then plus minus you can take m into delta b by b. Okay, then you will get the answer, that one. The maximum value of delta x by x equal to what, delta x by x equal to plus or minus n into delta a by a plus m into delta b by b. So I hope you got to know the concept. So thank you so much for listening patiently. So this is yours STB, student the brand. Thank you.